Okay, in this problem, I've got 0.2 kilomole of nitrogen, so it gives me the number of molecules I have. And this is in a piston cylinder, and it goes two processes. One's constant pressure, one's constant volume. Okay, so we want to find the work and the heat for the process. So what I want to do is I want to set up my states here. Okay, and I've got three of them. So the first, this is a constant pressure at 5 bar. That means P1 equals 5. P2 also equals 5. Okay, V1 is 1.33. V2 is 1. Okay. Then it goes constant volume, which means V3 also equals 1, right? Because V2 and V3 have to be the same. And the pressure, P3, is 4 bars. Okay, so again, maybe I'll just throw in on this one, that's bar, this is cubic meters. Okay, so two properties set my state. Okay, I've got nitrogen as my system. What do I want to look up? I want to look up my U values. Now, you'll remember that my U values over here depend on my temperature. This is, again, ideal gas. I'm using nitrogen, which is this guy over here, right? This is table A23. So I need to find those temperatures in order to look up my U values for nitrogen. Okay. The other thing you want to notice is that it's U bar, right? So that's based on kilojoules per kilomole, not kilogram, which is fine because we have the number of kilomoles. But what I need to do to set these states is I need to find the temperature of each one. And once I find the temperature, I can go over there and look up my U bar for each one in that table. Okay. Now, here's the other thing. Two properties set my state. So I can use the ideal gas model, because this is nitrogen at low pressure. Okay, I can use my ideal gas to find these temperatures. And you remember that my ideal gas equation, well, in this term right here, I would actually use P big V equals N R bar T. Okay, and I can use that because I have the number of kilomoles, so I can use R bar, which is based in kilomoles, and I got my PVs and my Rs and whatnot here. Okay. Okay, so using that, solving for T, I find that T then is going to be PB over NR bar, which, let me go ahead and do T1 here. P is going to be 5 times 10 to the 5th times V1, which is 1.33, divided by N, which is 0.2, times R bar, which is 8314. And from that, I get T1 equal to 400 Kelvin. Now, in order to save a little bit of time, I assume everyone can plug in the appropriate P and V here, right? So for the second one, T2, right, 1.33 is now 1. So that becomes 301 Kelvin. And then T3, my pressure goes to 4, and this is 1. So that's 241 Kelvin. Okay? But I use the ideal gas model to figure that out. Okay? So T1 is 400 Kelvin, T2 is 301, and T3 is 241. Now I'm going to go to my table for 400, 300, and 241 and calculate my U bar, and then I'll be able to go through and solve my work and my heat. So again, this is nitrogen. So I'm right here. What do I have? I have 400, 300, and 301. So 400 is right here. That makes U 8314. 301, well, here's 300. Let's see here. So instead of 6229, I do some interpolation between, it's 10% of the way between there. That makes this 6250 for temperature 301. And then at 241, same idea. I go 10% between these two, and that gives me pretty much 5,000 even between 4979 and 5181 for 241. So go ahead and jot those guys down. So I have 8314. I have 6250, and I have 5,000. Okay, so now I've set my states. Okay, knowing P and V, I was able to find temperature using the ideal gas model. Then I used that table to find U bar. Okay, so now, okay, my work, we'll start with work 1 to 2, right? That's a constant pressure process. So it's just P times V2 minus V1, right? Where P is 5 times 10 to the 5th. V2 is 1 cubic meter minus 1.33. Okay? And that gives me the work of negative 165 kilojoules. Okay? Now, 2 to 3 is a constant volume. Constant volume means delta V is 0, means the work from 2 to 3 is 0. Okay? Now, I'm going to use my first law equation, which is the change in U equals heat minus work, to find my heat. That means Q 1 to 2 then is N times U bar 2 minus U bar 1 plus work 1 to 2. What does that mean? Well, it means 0.2 kilomoles times these guys, which are, again, kilojoule per kilomole, as I looked up in the back of the book. So that'll be 6250 minus 8314, right? Minus 165, which is the work, gives me the heat here to be negative 578 kilojoules. Doing Q 2 to 3, again, I take 0.2, but this time it's 5,000 minus 6250. Okay, plus 0, right, because the work 2 to 3 is 0. That gives me Q 2 to 3 to be negative 250 kilojoules. Okay, so again, set your states using P and V and the ideal gas model, find T, then use the table to look up U bar. Once I have all of this, work is the relationship between P and V, and then I use the first law along with those U values and work to figure out my heat.